Hi everyone. In this video, I want to tell you the story of the little electric toy car you see behind me, how it came to be. First off, let's make it clear. This little car was basically built from scrap. Let's take a look at what it's made of. The base is an old ironing board, a broken ironing board. The rear seat and the part under the cushion are also made from the gridded part of the ironing board. The flat parts are from that. The wheels come from a handcart. The steering part is made from the broken wheel of a scooter, and there are some used car parts as well. For the steering, I had to use a pivot point, which I have here in my hand. It turned out so well that it can even get out of a swamp. So whenever we get the chance, my son and I go mud hunting with it. Now, let's take a look at the front suspension first. For the suspension, there's a pivot point here. It can handle several hundred kilograms, and it's a simple, inexpensive little mechanism. That's what forms the axle for the front wheel here. The same thing is on the other side as well, like this. Now, the other question is, how do we steer this thing? This part comes from an electrical cabinet. If you look closely, this is actually part of an eye bolt. You can get these at a hardware store. This is an eye bolt that's made of aluminum, typically used for grounding lightning rods, for example. The eye part is right here under the bolt. The bolt turns under the eye. You can guess whether the little film was thinking of BUDI 1 or BUDI 2, or maybe BUDI 2. I'll leave that as a mystery. This lamp here is the license plate light from a Gifa. The rear one, this one too, and this one as well. It's really cheap. I have no idea how they can make a lamp like this for so little money, but it's in the range of about 100 forints, maybe 200, but not much more. I think the bulb inside is worth more. By the way, since we're here, I'll show you. It even has a light. This is one of the tensioners for a car's ribbed belt. It comes from a car scrapyard, and there's another one above it, and with these, a shaft is mounted with bearings. And up there you can see, here is a huge gear, and this particular gear comes from a winch, specifically a hand-operated winch. This huge gear is securely welded to the shaft, and when the shaft moves, let me show you what happens, then the steering wheel moves as well, following the motion. The steering column comes over here, and everyone has a ratchet at home, or at least those who do mechanical work or repairs. So if you have a ratchet set at home, like a socket set, or perhaps even a more complete toolkit, you might be familiar with how these mechanisms work. Also known as a socket set. This is a 19mm socket head, and this is the universal joint drive shaft from the set. So, the steering rod moves the universal joint drive shaft like this. You have to turn the steering wheel almost a full rotation here to move the steering from one end stop to the other. So, the tower movement adjustment works like this. Here is a small tower, and here is another small tower. I connected the two with this pipe. This is the leg of a broken table, which is right here. It used to be the bottom part of an ironing board, which was once its leg. So this was the leg piece. It was bent here, and you could use it to support the ironing board. Altogether, this whole thing weighs about 25 kilograms now. The gas pedal is basically a door hinge, which is right here. If I press it, the gas pedal is a door hinge, and it has an electronic gas pedal inside. There's a cable, and basically pressing it sends a proportional signal here underneath through a potentiometer. If I turn on the device, it shows the battery's charge level. Right now, the battery is at 94% charge. There are two switches. One switch turns on the light. You can see there that the front light turned on. Now I'll turn it off, and the light is off. And with this, you can switch between forward and reverse. Now it's turned on, and if I gently press the gas pedal, you can see that the vehicle moves. If I switch it here to reverse, then it will go backward. Let me show you the back, because there are Eiffel lights on the rear as well. You can see here. Now I turn it on, then off. Here you can see the rear axle with the wheels, etc. The rear wheels also come from the Molnar cart, so basically there's something inside that we could call a fake differential. which means that one of the wheels is allowed to slip or rotate independently if the force applied on the axle exceeds a certain torque threshold. This particular component is a 6PKC, which is a type of pulley that is also commonly found in cars, where it is usually used to drive the air conditioning compressor or other similar auxiliary devices. 6PK refers to the fact that it has 6 grooves on its surface. If I zoom in a bit here, you can clearly see the 6 distinct grooves that are present on it, running parallel along the circumference of the pulley. These are strong belts. These belts need to be equipped with a tensioner. This tensioner, which also comes from a car scrapyard, so basically everything here is used: the belt, the pulley, and the tensioner as well. This is not a flux capacitor. For example, a car starter would have had enough power, but its duty cycle is too high, and it can only be operated for a very short time. For example, a windshield wiper motor would have had too little power, but its duty cycle would have been good. So there was a lot of searching, and eventually I found electric motors used in mobility scooters. The good thing about these is, for one, they have a brake here. This shiny part, which is kind of the color of cadmium. So this cadmium-colored part is a brake. Basically, it's like an electric handbrake, and it ensures through the belt that the wheels stay put. Now, I'll try to pull it. You see, the vehicle moves, but the wheels don't turn because the brake is holding them. These are big. With this gear ratio, you get a running pace, about 8 kilometers per hour as the maximum speed. This top speed is perfectly sufficient for off-road, grass, meadows, fields, and hills. But what's really great is that there's 300 newton meters of torque at the wheel. Let's look at the backrest part. This is also made from the so-called leg of the ironing board. This part here is actually a drawer slide. You can see the drawer. The slide should have been fixed to the furniture board here. This part is also from an old drawer slide. The seat itself is a leather seat, made from an old jacket, and underneath it is also the rack from the ironing board, which would normally be there. The big advantage of this is that if water gets on it, it drains out immediately. So even if this little vehicle goes into a bit of a swamp, the water just flows right out. There are 2 junction boxes. This is one, and this is the other. Each of them has a battery. This one has a 26-volt 8 amp hour battery, and this one has a 40-volt 4 amp hour battery. By default, the 40-volt battery powers this motor, and the 26-volt one continuously, as long as it has energy, tries to charge the 40-volt battery. The advantage of this is that if the 40-volt battery runs out and this little vehicle gets stranded somewhere out in the field or on the hills, then all you have to do is simply turn the whole thing off with that little front console and wait for the 26-volt unit to gradually charge up the 40-volt one. So even if someone is, let's say, not paying attention or is careless enough to completely drain the battery, they'll still be able to get home. You just have to wait for about 10 or 15 minutes, and then the 26-volt unit will quite nicely recharge the 40-volt one. So its only real purpose is really to provide this kind of extra idiot-proof protection. If the main battery runs out of power, you either have to push it or wait. Of course, I can't fully use the battery's capacity this way, but if you really need the full capacity, it's no problem. You just have to wait about 15 minutes for the small battery to get the big one back in shape. So there's an inverter inside that converts the 40 volts into 24 volts for the motor. It controls the motor's RPM with voltage, which the harder you press the accelerator pedal. In other words, the more you push it down, the higher the voltage the motor receives, and accordingly, the faster the vehicle goes. This belt can really get yanked by the 300 newton meters of torque, but so far, the belt hasn't snapped. It's true that sometimes you have to apply some anti-slip spray, because under such huge torque, the belt can occasionally slip. Well, that's about it. I hope you enjoyed the video. So, this was BUDI 2. See you later.